I'm Ronit Sachdev, and this is all about Karl Friston. So his early interest in science stemmed from both of his parents being involved in science, as his mother was a nurse and his father was an engineer fascinated by physics. And as for education, he studied both medicine and physics at the University of Cambridge, which actually ended up being his biggest obstacle, as he did not know whether he wanted to become a doctor or a researcher. So he spent 8 years in that contemplation, first getting his degrees at the University of Cambridge and then getting his MBBS at King's College. And so he spent 8 years trying to become a doctor and even became a member of the Royal College of Psychiatrists before realizing that he actually wanted to become a neuroscience researcher. But he overcame this obstacle by saying that his time in medicine was useful to him, as every scientist is taken more seriously if they have a medicine background. So now about his career, he is a professor of neuroscience at the University of College London and a scientific director of the Wellcome Center for Human Neuroimaging. He also recently joined Versus in 2022 as their chief scientist. So the question that he studies is how does the brain make predictions based on what the sensory organs see and sense. So his hobbies are contemplative mornings, where he just spends hours in the early parts of the day just thinking about life. And as a result of this happening literally every day, he arrives to work at around 12 or 1 every single day. He also likes smoking a pipe and reading for pleasure. And I admire how he takes initiative in learning new things. So with the rise of AI, a lot of new breakthroughs have been made in neuroscience, and he took initiative and started learning more about AI as a result. And I really admire that. I also admire how curious he is about the world, and that's also a way in which I identify with him, as I'm also very curious about how many things in the world work. I also identify with him because I'm also studying neuroscience, and I'm very interested in neuroscience like him. Now, on to his primary document called From Pixels to Planning Scale Free Active Inference. This was actually an article that built upon a different article that he published in 2020 called Active Inference on Discrete State Spaces. So this experiment was basically trying to see how a computer could learn and then use that learning to make decisions. The reason for doing this was to see if a computer could act like a brain. But the big overarching reason for Karl Friston to do this was to learn AI better. So the procedure for this was that they built a computer model with different levels of learning. The lower levels focused on simple details like shapes or pixels, while the higher levels combined these details to make decisions. And the conclusion was that yes, a computer can act like a brain. So this is one of 25 figures, and it's figure 3, and all these figures contributed to that overall experimental conclusion. So this figure basically answered the question of how can a brain think and learn across multiple levels. So this figure shows the computer model that was supposed to act like a brain, which is called the renormalizing generative model. So the little circles that over here act as and signify the lower and higher levels of thinking that this computer has. So the ones that are higher up on the page are the higher levels, while the ones that are lower are the lower levels. And each layer predicts a layer below it, and the square boxes represent the mathematical links that describe how the lower and higher states depend on each other. So these little boxes over here. And then the red dash box over here represents how several fast lower level states can be grouped together and predicted by single slower higher level states. So these can be predicted by only like one of these. So like how many lower level ones can be predicted by just like one or two of these higher level ones. So the techniques used were computational modeling, so a computer simulation of higher and lower level thinking was used, a hierarchical generative model, which basically meant that yeah, this model has layers, and then active inference framework, which was basically that they framed this whole experiment on active inference, which was the idea that the brain constantly tries to reduce surprise to predicting what will happen next, which is something that this experiment was trying to simulate. So what all this means is, how I understand it is I put all this computer stuff and base it in my own brain. Like how would this work in my brain? So the lower level would be my sensory organs, so the higher level would be my brain. So let's say I say, oh, there's something red and round in front of me. My brain would say, oh, that's probably an apple, and I would send a prediction down to the lower level. Oh, that should probably smell sweet, and that would reduce the amount of surprise and make everything a lot less stressful for a brain. So the controls that were used was a non-hierarchical model, which shows what would happen without the slow versus fast separation, and then a fixed prior version where the top layers couldn't influence lower ones. And these controls were used to prove that RGM success came from its layered brain-like structure rather than from luck or random chance. And if both these controls are worse at predicting and planning, then the experimental model happened due to the computer acting like a brain. And this is exactly what happened. The computer acted like a brain. And now some discoveries that he's made are active inference, the free energy principle, and he's trying to make new conclusions about AI as a chief scientist at Versus AI. And in conclusion, He is a British neuroscientist and theoretical thinker who developed many principles and now is working in artificial intelligence. Thank you.